Good morning, boys and girls, and welcome to math class. Today we are going to be looking at estimating and measuring liquid volume, and we are going to take a look at two videos as a really great introduction because we would usually go to Math Lab and Mr. Nitch would use all kinds of different manipulatives for you to see how we measure liquid volume. So like water, juice, anything that is a liquid has a certain way that you measure it. So you can find out how much space it actually fills. So we are going to do a couple of quick videos just so you can see measuring liquid volume in action. Hopefully we can get this started.
Any liquid inside a container will have what is called a volume. The water in this container has volume. And the water in this container also has volume. What is volume exactly? Let's focus on this bottle over here. Volume refers to the amount of space taken up by the liquid. But how do we measure volume? For example, what is the volume of the water in this container? We use a standard unit for measuring volume called the liter. This bottle, for example, contains 1 liter of water. And this bottle contains 1 liter of milk. And this one has 1 liter of juice. As you can see, these bottles look different, but they all contain the same volume of liquid, which is 1 liter. In this lesson, you learned about the standard unit for measuring volume.
Hey everybody, this is Mr. Mathblog, and this lesson is estimate and measure liquid volume. Okay, so we're going to deal with metric units here, so don't forget all your lessons can be found at mrmathblog.com, and this is lesson 10.7 in the textbook we're following. So there's our common core strand. Our essential question is, how can we estimate and measure liquid volume in metric units? Okay, so liquid volume is the amount of liquid that goes in a container, like a glass or maybe a soda bottle or a water bottle or something, that you can fill up some liquid. So typically we're going to deal with water. So the liter, which is, we'll use a capital L, you guys, is the basic metric unit for measuring liquid volume. So we'll get into more of that later. So just think of the size of, say, like a teacup that you have tea in, okay? So something that looks like that right there, okay? So there's a teacup right there. So if we poured 2 of these into here, it would fill it up to right there. And most of you guys probably have one of these. Your mom or dad has one of these in the cupboard, or maybe your grandma does. Inside their cupboard right there, and it's typically 2 cups right there, okay? So let me move that over right there. So if we doubled this size, it would give us 4 cups. So if we poured 2 of these into here, it would fill this one up right here. So if 2 of these fills this one up, and then 2 of these fills this one up, how many of these need to go into here? Well, if you can read that, it says 4 cups right there. So 4 cups, you guys, is the same as, or it's almost the same as about a liter. In fact, if you had one of these with 4 cups on it, if you turned it around, if you can see through that, there's some writing on the backside. It's this right here, probably. It says how many liters are in there, okay? So I don't know if you can see that backwards right there. It says 4 cups right there. Well, on the back side, it says 1 liter. So these containers are the same containers right here. And 4 cups is about a liter. In fact, 4 cups is a little bit less than a liter. It takes you a little bit takes you about 4.22 cups to equal 1 liter right there. So, but both these cups can hold that. So think of a water bottle that you buy inside the grocery store or inside the gas station store or something, you guys. That's usually in the liter bottle right there. And if, sometimes they're smaller, sometimes they're larger. So let's think, say your classroom's going to have a big party and you buy these things. These are called 2 liters right here. Okay, and if you guys like Coke better, well, then here's a 2 liter Coke bottle right here. Okay, I'm not promoting soda, you guys, because soda has so much sugar in it. In fact, one of these bottles has about 56 sugar cubes in it from just how much sugar's in there. That's a lot of sugar. So I hope you guys aren't drinking too much of that. It's just not good for you. I've got to admit, I do like a cold soda every now and then, but there's a lot of sugar in there. So estimate how much liquid volume there will be when each container is filled. So all I want you to do is to write more than 1 liter, or it's about 1 liter, or less than 1 liter. Okay, this one is about 1 liter. Let's just use this as our guiding post right here. This is about 1 liter. Can't you see that that this is definitely smaller than this right here, and this guy is definitely larger than this? So what we're going to do is we're going to say this one is more than 1 liter. Okay, that's what they want us to know. This one is less than 1 liter, and then this one's about 1 liter right there. Okay, how about these guys right here? A spoonful of water. Well, that's definitely less than 1 liter. How about if we fill a bathtub up halfway full? Well, I can fit a lot of those liter bottles in there, so that's going to be a lot more than 1 liter right there. And then this little eyedropper is definitely less than 1 liter, okay? All right, so use the picture to answer each, and each of these glasses are the same size. Okay, so which glass has the least amount of water out of all of these? Well, it looks like this one is glass C has the smallest amount. Which glass has the most amount of water? Which one's filled up to the top? This one is glass B is right here. Okay, this one says place the glasses in order from the least to the greatest. So this one looks like it's the least, so I'll slide that one right here. This one looks like it's the next one, so it would go right here. So this one's the next one right here. And then finally, this guy is going to be the fullest one right there. Okay, so if we placed them in order, then we'd go C, A, D, B right there. Okay. All right, what else? So let's see. Beverly filled the bathroom sink with water. About how much water does she put in? Does she put in about 1 liter? Okay, she fills the bathroom sinks. Think of the sink in your bathroom. Think about pouring that water bottle in there. Would it fill up that sink? I don't think so. So if she fills up the sink, do you think she's going to have more than 1 liter in it, or much less than 1 liter, or a little less than 1 liter? Well, I think it's definitely more than 1 liter. She can probably, put in 5 of those bottles in there, okay? How about this? Sandra needed about 1 liter of water to fill a container. Which container did Sandra most likely fill? So which one is most likely about 1 liter? How about a small glass? Okay, well, remember that cup right there? That's like a small glass in the beginning of the lesson right there. It's not this one, because this one's less than 1 liter. How about a spoon? No, that's less than 1 liter. How about a large bucket? Well, I can pour several of those water bottles in a large bucket, so it's definitely not that one. How about a vase to put flowers in? I think it would be this one right here, so it would be a vase right there. Okay, you guys? All right, that's all we're going to do on that. And if you guys can, click like and take care.
Okay, so we are back, and I hope that kind of gave you a little bit of a reference for when we start talking about the different problems in your math book. So if you could please turn to page 599 in your Go Math book, we're going to get started. Now, it says estimate and measure liquid volume. Like I said, we're not going to be measuring, but you saw 2 videos on sizes and how much liquid could fit into each of those little containers. So right here it says, how can you estimate and measure liquid volume in units? Okay, so we're going to be talking about liquid volume and the amount of liquid in a container. Now we've been talking about liters. Now you'll see there that a liter is a capital L right here. That's the abbreviation, is the basic metric unit for measuring liquid volume. Now, we talk in customary measurements in the United States, this is a metric unit of measuring. So this is something that you'll need to become more familiar with as you get older, because science and math does a lot with the metric system. So we'll move away from the customary like cups and half gallons, and we'll move into liters, milliliters, more of the metric system. Okay, so we have an activity here which was already done for us when we looked at that video. So he showed you a liter beaker, and he showed you it looked just like this, okay? And it had about 4 cups in it, if you remember. So 1 liter of water into a container, mark the level of the water with a piece of tape, draw the container below, and name the container. So he showed us different containers, so we're going to go past this page, and we're going to go to page 600 so that you can see some more examples. So a full glass of water holds less than 1 liter. So remember, he was talking, he showed you teacups, and he had 4 cups, if you remember the breakdown. And then he showed you how the 4 cups would pretty much fill that 1 container, and that was about a liter. And there's your water bottle, which has about 4 cups of water in it, and that's the kind that you buy at gas stations. Remember, he was saying gas stations, he was showing you a picture of it. So there's your water bottle that you guys put on the side of your desk. And then a fishbowl holds more than a liter. So to fill this fishbowl up, you would have to fill this liter bottle up a couple of times, okay? But if you poured this into this cup, you'd be able to fill this cup multiple times using the amount of liquid that you have in this liter container. All right, so we're going to just look at this. It says materials, 1 liter beaker, 5 different containers, and some water. So we are not going to do that. I have here a 2 liter bottle of Coca-Cola, my favorite, which we learned some horrifying information about how much sugar is in pop. So I guess I'm gonna have to stop drinking my favorite red Coca-Cola every day, but I will feel better because I'll be healthier. So this is a 2 liter bottle. So if you think about this 1 liter, how many liters are in a 2 liter? So if you kind of divide a 2 liter bottle straight down the middle, you can see that this side is 1 liter and this side would be the other liter. So there's 2 liter bottle of pop would have 2 liters in it. Next we have a quart of milk. Now a quart of milk, remember he was telling you, the quart is like 1 liter. And then I got one more, and this bucket, what do you think? Do you think you would have to have more than 1 liter to fill this? So if you think about it, you could draw lines going across, so maybe that might be 1 liter, 2 liters, 3 liters. So you can see that if you took this amount, 1 liter of this pop, of this 2 liter pop, and poured it in here, you might have to fill that up multiple times. So this 1 liter bottle would not fill up this bucket. You'd have to fill it up, pour it in, fill it up, pour it in. Okay? So we're going to move past that because I'm not with you and I can't do that with you. So I apologize. but we'll make the best of it. So the share and show, I will pull that up at the end. So we're going to go to the beaker. Here's our beaker is filled with water. Is the amount more than a liter, about a liter, or less than a liter? So think about the video that we watched. And we know that he took, remember, he had like teacups and he kept pouring them in. And he said he had about 4 cups would equal the liter. And he showed you the top that said 1 liter. Okay, so we know that it is about 1 liter. Okay, so we'll just underline it is, oops, it is about 1 liter. So we know it is about 1 liter there. Let's see if I can get my pen to work. There we go. It is about a liter. All right. So it says estimate how much liquid volume there will be when the container is filled. Write more than a liter, about 1 liter, or less than. So I'm going to write an M if it's more. I'll just write 1 if it's 1 liter, and I'll put an L if it's less than. So a cup of tea. Think about that 1 liter bottle. Now, what do you think? Do you think it is a cup of tea is more than, less than, or equal to? So you are right, it is less than. How about the kitchen sink? So think about your mom when she's doing the dishes. Is she only using 1 of those liters, or is she using maybe like a 2-liter pop bottle amount? So you're right, it is more than. And how about a teacup? When you fill that teapot up, a teapot. So we know that 1 cup of tea is less than, but think about, does this teapot hold more than 1 cup of tea? Can you hold more than 1 cup of tea in this teapot? Absolutely. But do you think you're filling up sinkfuls of water with a teacup? No. So it would be 1 liter. So it would be 1 liter. All right, so on your own, estimate how much liquid volume there will be when the container is filled. Right, more than 1 liter, about a liter, or less than a liter. So let's look at this picture. So think about, just look at this right here. This bottle right here is 1 liter. Okay? So do you think this pitcher has 1 of those, less than 1 of those, or more than? So hopefully you're seeing that it has 1 liter in it. It's just about 1 liter. Now that juice box is just 1 juice box. So think about a juice box. If you took this liter bottle down here and you look at that, how many juice boxes are you thinking that you could fit in this liter bottle? So you're right, it's more than. So this juice box is less than 1 liter. You could fill many juice boxes with a liter, so it's less than. And then if you look at this punch bowl and you think of these bottles down here, do you think that it could hold more than 1 liter, less than a liter, or just a liter? And you are right, you could hold more than 1. When you look at these bottles down below, you can tell that you could put more than 1 of those in that punch bowl. All right, so it says use the pictures 8 through 10 to answer 8 through 10. Rosaria pours juice into 4 bottles that are the same size. Did Rosaria pour the same amount into each bottle? So if you look at that, you can tell that this one goes to here, then to here, up the top, and here. So you can see that the liquid volume in each of those bottles is different. So that would be no. So which bottle has the least amount of juice? Hopefully you compare them and you can see which bottle has the least amount of juice. Hopefully you can see that it is X. And then which bottle has the most juice? And that would be W. Now, my book is different. Mine says that W has the least amount and the most is Y. So I'm not sure if your book is like my book and is different from the PowerPoint here or my Smartboard lesson. All right. So problem solving. Hopefully you're on page 602. Use the containers for 11 through 13. So we're looking at these containers over here. These are all a cylinder. And it says container A, here's container A is full when 1 liter of water is poured. So this is equal to 1 liter. I was trying to write it equals to. Let me see if I can erase that. Okay, so A is equal to 1 liter. Okay, so just remember that this right here, this one right here is equal to 1 liter. Okay, that's going to be really important. So it says estimate. So estimate means, remember, estimating means that it is not an exact amount, it's a rounded amount. So estimate how many liters will fill container C and how many liters will fill container E. Which container will hold more water when filled? So if you take this right here and you put it into container C. So we're going to go to container C. So you're going to look at that with your maybe your finger and you can see, okay, well to like right here would be 1. So maybe you need to fill that at least 3 times. Okay. And then how many liters will fill container E? Well, look at C and how thick it is. And we're going to take a straight line and we are going to cut this straight down the middle. And you can see that E is about half of that, okay? So maybe you're thinking that C has about 2.5, 3 liters. So depending on how you broke yours apart, maybe you thought that I didn't do that and I needed to put it a little bit more in half here. I guess that looks better. Okay, so let's say container C equals 2. C equals 2 liters. So that means that E is half of that, so E would equal 1 liter. Okay? So it's all about adjusting. And remember, it's math, so the first time, sometimes the first time isn't the correct way. Maybe you need to go back and erase and look at it again. Like I started looking at that and I started thinking, oh, I think I made it too small. All right, so we're going to move on to 12. Name 2 containers that will be filled with about the same amount of liters. Okay, so you got to really look at that. So let's see. We have this guy here is short and this guy's thin. So kind of what if I turned this on its side? I don't know. What do you think? We have A. He's kind of short. Now these guys are definitely different. So I feel like we could take them out of the mix here. So like we could just put an X and an X. Like those ones are really a lot different in size, so they would not be the same. We're looking for the same. So I'm thinking we need to look at these 3. So I'm still thinking B, and A. I just feel like this one's too thin. So I'm thinking container B is shorter and wider than container A. So it's going to maybe hold the same amount. So if I like cut this in half and I stacked it on top, maybe it would be as tall as this. So they might be the same. That's my thought. Okay, 13. What's the error? Samuel says that you can pour more liters of water in container B than into container D. Ugh. He thinks you can pour more into container B than D. Well, if you think about that, it's not possible if you ask me. Container B is smaller than D. D is much taller, so it can hold more liters of water when it's filled. So hopefully you're seeing that. All right, we're going to move on down to 14. Says the bottle of tea holds about 1 liter. For numbers 14A to 14E, choose yes or no to tell whether it will hold more than a liter. So more. Okay, so a teacup? No. Hopefully you're doing this. Kitchen trash can? Absolutely. A small pool? Well, if you only want to go swimming with this tiny little bit of water, that sounds terrible. So we're going to go with it can definitely hold more. A fish tank we saw can hold more. And then a perfume bottle. Perfume bottles do not come in big bottles like this. They're usually dainty and small. And so that would be a no. All right, so you're going to do the practice and the homework by yourself. So you are going to complete this page and then you're going to complete your lesson check and then come back and I'll give you the answers. So pause the video. All right, so you are back. I'm glad that you are back. And so we are going to estimate and measure the liquid volume. So it says estimate how much liquid volume there will be when the container is filled, right? More than a liter, about a liter, or less than. So you can see here that this is a large milk container, so it will definitely be more. This is a small milk container, so it would be less. This is just a regular water bottle, so we've talked about that. That's exactly the size that about a liter would be. So I shouldn't say exactly because we're doing about, which is a rounding, which is not an exact. Okay, it's an estimate. A spoonful of water definitely would be less than, a bathtub would be more than, and an eyedropper would be less than. All right, so using the pictures here, A, B, C, or D, which glass has the most amount of water? So you should have D. And then name a container that you see at home that would be, that when filled, has a liquid volume of about. Keyword about, not exact. So maybe you want to say the dog's dish, maybe a soap dispenser or a coffee pot. All of those would work. The lesson check number 1, the answer is more than. Number 2 is a vase. Your spiral review is 6 glasses. Number 4 is 3 muffins. You had 12, putting 1/4 of the muffins in the bag. So that means you have to break it up into 4 equal groups. Okay, and so that would be 3 in each group. So hopefully you broke it up into 4 groups of 3. All right, what time is shown on the clock? We did a lot of review of time. Hopefully you drew out the hour, circled the lower hour, drew out the minute hand, and then skip counted around by 5s, and then added your minute. So that would be 6:56 or 4 minutes before 7. And then number 6 was 1 3/4. And I hope you guys had a wonderful lesson. I miss you all. I hope you're really keeping up with your studies because I want you to be ready for 4th grade. I can't believe it's going to be right around the corner and you're going to be 4th graders. So Keep up the good work. I'm so proud of you, and I hope you have a wonderful day.